Now we come towards surface energy and surface energy density. We are referring to surface. It means we are referring to energy. So surface means that the area of surface, and energy means that how far the surface will expand or contract. And surface energy density means that how many molecules are there in a given area. So that is what the meaning of surface energy density, or we can take the three-dimensional view, that is the volume. The energy of a molecule in the surface layer of liquid is more than the energy of a molecule in the interior. So now what exactly is the meaning of this contact? That is, it is mentioned that energy of a molecule in the surface layer. When the molecule is just on the layer of the surface, then it has got different surface energy, and when the molecule is within the water, then it is also experiencing the force due to other molecules. So the energy of molecule in the surface layer of the liquid is more than the energy of a molecule in the interior. When a molecule is brought from interior to the surface layer, work has to be done against the attractive force, and the energy spent is stored in the form of energy. Now, what is our context? When the molecule is brought from interior to the surface. So when we have to bring a molecule from the interior of the liquid to the surface, then that molecule which is within the liquid is experiencing force due to other molecules. So to bring it to the surface, some external work is to be done, and that work gets stored in the form of potential energy. The surface energy per unit area is called surface energy density. So what is SED, surface energy density? It is surface energy per unit area. Now surface energy will be in joules and area will be in meters square. So it is joule per meter square. So surface energy density is equal to surface tension, that is E is equal to delta W over delta A, and that is equal to T. The unit of surface energy density, as I have explained earlier, it is joule per meter square or per centimeter square. SED stands for surface energy density. This is equal to E over A or W over A. Dimensions of surface energy density are that is M1, L0, T minus 2. This what we have done is that in SED equation there is W and A. For W we have put the dimensions of work, that is force into length, divided by the dimension of area. Area will be L square. Now angle of contact. To understand the angle of contact, we have to go through the figure. So we have taken the two figures A and B. In one case, it is glass in the form of a tube. The point of contact is indicated, and in the left side figure there is water, and in the right side figure there is mercury. We find that in the glass and water, we find that the point where the molecules are just in contact, we draw at that point a tangent on the meniscus, and that angle is called the angle of contact. So it is within the water, and the surface of the water in the capillary will be a concave surface. But if it is in the glass tube mercury, then the surface or the meniscus will be convex, and the angle of contact will be, that is, angle between the glass surface and the tangent drawn on the arc, that is the meniscus, that is the angle of contact. So that is shown here, that is theta in water is less, whereas theta in that is mercury is more. Angle of contact in mercury is more. Now the context is the angle inside the liquid between the tangents drawn on the solid surface and the liquid surface at a point of contact is called the angle of contact for the pair of solid and liquid. So that is what's shown in the two figures. For a pair of solid and liquid, the angle of contact remains constant and it does not depend upon the inclination of the solid surface. The angle of contact is found to be between 0 and 180 degrees. Those liquids which wet the solids have angle of contact less than 90 as shown in water, and which do not wet the surface have angle of contact greater than 90, that is shown in case of mercury, that is the second figure. So the figures are again shown to understand the angle of contact. So in the second figure where there is mercury, the angle of contact is more than 90, whereas in case of angle of contact, in case of water, we find it is less than 90. For pure water and clean glass, when there is no impurity, theta will be taken as 0. For alcohol and the clean glass, it is equivalent to 0 but not exactly 0. For mercury and glass, it is 138 degrees, that is greater than 90 degrees. Angle of contact for silver and water, that is equivalent to 90 degrees. So these are facts to remember, and on increasing the temperature, the angle of contact decreases. So as the temperature of the liquids go on increasing, we find that the angle of contact goes on decreasing. Shape of the meniscus. So I have just now explained about the shape of meniscus. If we consider a capillary tube, we dip it in the liquid like water or like mercury, we find that against the atmospheric pressure, some liquid will rise into the tube, that is, water will rise into the tube or mercury will rise into the tube. In order to understand this capillary action, one must be aware of that for a capillary, if the diameter is more for the tube, the atmospheric pressure, that is P is equal to HdG, acting on the surface will be more. So that's why if the diameter is more, then the liquid rise in the capillary will be less. Therefore, when we speak capillary, it is a fine bore tube having very, very less radius. So shape of the meniscus. In case of water, it is a concave surface, whereas in case of mercury, it is a convex surface. The curved free surface of the liquid in capillary is called meniscus. It can be concave or convex. The shape of the meniscus depends upon the resultant of the cohesive force in a liquid and adhesive force between the solid and liquid. As I have explained earlier, cohesive force means the forces among the same type of molecules, whereas adhesive force means the forces among the two different types of molecules, that is solids and liquids. Now, the figure is shown, that is a tube is dipped into water, and the other figure, the tube is dipped into mercury. The water will rise in the tube, it will rise more, whereas the mercury will rise less, its density is more. So diameter of the tube is same in both cases. Atmospheric pressure is also acting the same, but the upthrust is more in water as compared to mercury. Therefore, the meniscus of mercury is convex, whereas the meniscus of water is concave. The curved free surface of the liquid in a capillary is called meniscus. The shape of the meniscus depends upon the resultant of the cohesive force in liquid and adhesive force between the solid and liquid. When the adhesive forces for liquid solid, that is Fa, that is adhesive force, it is 1 over root 2 times of the cohesive force. 1 over root 2 means tangent 45, that is angle of contact is 45 degrees. Then the surface of liquid is plane and theta will be 90. Now, Fa stands for the cohesive force and Fa stands for the adhesive force and Fc stands for the cohesive force. If the adhesive force is less than cohesive force divided by root 2, then theta will be greater than 90 and the surface of the liquid is convex. So that can be the reason that why mercury meniscus is convex. and Fa, that is the adhesive force, means that is Fa means adhesive force. Now again the same figure is there, and in mercury a convex meniscus indicated, and in water the meniscus is concave, and angle between the molecule and glass surface and the tangent drawn on the surface is theta, that is called angle of contact, and sigma represents the surface tension. So surface tension is force per unit length, and atmospheric pressure is acting on water, and that atmospheric pressure is HdG. That is same for water as well as mercury, but the rise will be more in water and it will be less in mercury, and the surface in case of mercury will be convex, that is the meniscus, and in case of water it can be concave. Now adhesive force is greater than cohesive force divided by √2, then theta will be greater than 90 degrees. The meniscus is concave, and Fc means the cohesive force. The surface of the liquid in meniscus is normal to the resultant of adhesive force and cohesive force because the liquid surface cannot bear the tangential shearing force for a long time. It is momentary basically. Now in the figure again, we have taken a container, and where it is blue, it is water, and where it is the right side, that is black portion or the gray portion, it is for mercury. So if the capillary have the same diameter, the rise of water is more as compared to mercury, and the meniscus in water will be concave, whereas the meniscus in case of mercury will be convex. So the surface of liquid in meniscus is normal to the resultant of Fa, that is the adhesive force, and Fc, that is the cohesive force, because the liquid surface cannot bear the tangential shearing force.